regulation of metabolic reactions depends on both the chemical environment that's within our body cells, things like the level of ATP and oxygen, but also on signals from the nervous system and the endocrine system. Some parts of metabolism depend on how much time it's been since you ate your last meal. During the absorptive state, the nutrients that have been digested are entering the bloodstream, and glucose level is very high, and we've got plenty of glucose available to make ATP. During post-absorptive, remember post means after, during the post-absorptive state, nutrient absorption is complete, and energy needs have to be met by the fuels that are already in the body. A typical meal requires about 4 hours for complete absorption. Now, if you eat 3 meals a day, that means that the typical absorptive state is about 12 hours each day. Now, if you don't eat any snacks between meals, the other 12 hours, which is usually in the late morning, the late afternoon, and most of the night, is in the post-absorptive state. Because the nervous system and the red blood cells continue to always depend on glucose for ATP production during the post-absorptive state, maintaining a regular blood glucose level is critical during this post-absorptive time when we're not taking nutrients in. So hormones are the major regulators of metabolism in each state. The effects of insulin dominate the absorptive state, and several others that you learn during the digestive system or during our discussion of digestion, but also the endocrine system, things that increase blood glucose level are going to regulate metabolism during that post-absorptive state. During fasting and starvation, many of your body cells are going to use ketone bodies to produce ATP. So we'll look at a couple of terms related to that, and the first is fasting, which means going without food for several hours or even a few days. Starvation is going weeks or months because you are deprived of food or have inadequate food intake. People can survive without food for about 2 months or more, as long as they stay hydrated, drink plenty of water, and of course that's going to prevent dehydration. But your glycogen stores are going to be depleted within a few hours after you begin fasting. Catabolism of stored triglycerides and structural proteins can provide the energy that you need for several weeks. Basically, your body starts to break down stored fats and stored proteins. The amount of adipose tissue in the body is going to determine how long you can live without food. During fasting and starvation, the nervous tissue and the red blood cells, as I mentioned a while ago, are going to continue to use a lot of glucose to make ATP. But there's a ready supply of amino acids for gluconeogenesis, making new glucose from non-protein or from non-carbs, because that lowered insulin level and increased cortisol is going to slow the pace of protein synthesis. So we slow down the rate at which we make proteins. Therefore, we can use those proteins, catabolism, to use that amino acid to make ATP. The most dramatic metabolic change that happens when a person is fasting or is in starvation is the increase in the formation of ketone bodies by the hepatocytes. So when glucose levels are low or glucose can't enter the body cells, such as a patient with diabetes mellitus, most body cells are going to use fatty acids to create ATP. And one of the byproducts of using fatty acids to create ATP or fatty acid catabolism are ketones. Ketones are lipid soluble, so they can diffuse across the plasma membranes and across the blood-brain barrier and be used as an alternative fuel source to make ATP, especially by cardiac and skeletal muscle fibers and neurons. Normally there's only a trace of ketones or ketone bodies present in the blood, so they're not really much of a fuel source under normal conditions. But after a couple of days of fasting, the level of ketones rises up to about 100 to 300 times higher than normal and can supply about a third of the brain's fuel, making ATP, right? By about 40 days of starvation, ketones provide about 2/3 of the brain's energy needs. So as I just mentioned, the level of ketone bodies in the blood is normally very low because other tissues use these ketone bodies to make ATP just as fast as we produce them when we're breaking down those fatty acids. But when the concentration of the ketones in the blood rises above normal, that's a condition called ketosis. So the ketone bodies, most of them are acids, have to be buffered because if too many accumulate, they decrease the concentration of buffers, such as bicarbonate ions, and blood pH falls. Remember, decrease in pH, more acidic. So extreme or prolonged ketosis can lead to ketoacidosis, where the blood pH is abnormally low. This decreased pH can cause depression of the central nervous system, which can result in disorientation, coma, or even death if the condition is not treated. So when a diabetic becomes seriously insulin deficient, one of the signs is the sweet smell of the breath because the ketone bodies have a smell very much like acetone.